Greetings to all. Myself Vaishnavi, Assistant Professor IT Department from SNS College of Engineering. Now we are going to see about the mass storage structure in the operating systems. Mass storage structures. One of the responsibility of the operating system is to use the hardware efficiently. For the disk drives, the fast access time and the high disk bandwidth. The access time has the two major components. First one, the seek time. The seek time is the time for the disk arm to move the heads to the cylinder containing the desired sector. Next one, the rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk head. The next point, the disk bandwidth is the total number of bytes transferred divided by the total time between the first request for the services and the completion of the last transfer. We can improve both the access time and the bandwidth by the disk scheduling. So, servicing of the disk input output request in some good order. Next one, disk scheduling. We have the five types of disk scheduling. First one is FCFS, that is first come first serve scheduling. Second one SSTF, that is shortest seek time first scheduling. Third one is scan scheduling. Fourth one is C scan scheduling, and fifth one will be the look scheduling. First one is the SSTF, that is shortest seek time first scheduling. It services all the requests close to the current head position before moving the head far away to the service other requests. That is to select the request within the minimum seek time from the current head position. Here the queue number will be given, and then the starting position of the head also given. It start from the 53, and then it goes to the next we have to see which is the shortest seeking time. So after the 53 the number will be the 65, and then it goes to the 67, and then followed by 37, and then 37 to 14, and 14 to 98, like this it goes on. For the shortest seek time we have to see the smallest value. Next one is the scan scheduling. The disk head starts at one end of the disk and moves towards the other end. It is servicing the request as it reaches the east cylinder until it gets to the other end of the disk. At the other end, the direction of the head movement is reversed and the servicing continues. The head continuously scans back and forth across the disk. Here we have the example. As it is earlier seen, in the Q values also given and the starting position of the head also given. For the scan scheduling, it starts from the 53 to 53 and goes to the 37. After visiting the 37 block, it goes to 14. After 14, it completely goes to 0. That is the starting position, and then from the 0 it goes to the next value, that is 65, and followed by 65 it goes to 67, and then 98, and then 122, 124, and it ends with the end position of the 183. Next one is the C-scan scheduling variant of the scan designed to provide the more uniform wait time. It moves the head from one end to the disk to the other. It's servicing the request along the way. When the head reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request on the return type. The same queue number, and then head, the starting position of the head will be the 53. So from 53 it goes to 65, and then 65, 67, and followed by the 67 it goes to 98, and then 122, 124, and finally after the 124 it goes to 183. After 183 it reaches the end position, that is 199. After completing the 199 it automatically goes to the initial stage, that is 0. Next one is look scheduling. Both the scan and the C scan move the disk arm across the full width of the disk. Here we have the diagram for the look scheduling. It starts from 53 to 65 and then 67. It goes to 98 and then 122, 124. As it goes to 183, after 183 it goes to the smallest number, that is 14 and then 37. Thank you.